Hello, can everyone hear me? Okay, thank you. We didn't have class on Monday. In the quiz tomorrow, it will cover all chapter 4. So I feel like we have to cover lots of content for today's tutorial. And then I believe that on Monday will be our last tutorial, like Monday next week. It's 2:10, so I will start. We first want to review the 5 concepts here. I couldn't find tutorial 9 on Quarkus. I didn't post it yet. Let me see. I can post it now, just so you have the questions with you. I was so busy this week, so I couldn't type in LaTeX. So I just wrote the question down. Tutorial 9. Okay, if you go to the Google Drive link, you will see tutorial 9 folder, and I just post it there. So we first want to talk about what is random variable. Random variable is actually just a function, and it maps from the simple space to some real number. For example, think about the experiments that you toss a coin. Then you would have 2 outcomes, right? Your simple space would be either head or tail. So what a random variable do is it map each outcome to some number. It depends on how you define a random variable. If you define a random variable x as the number of heads, then what x do is if you have the outcome head, then by random variable x, head will be mapped to 1. Why is that? Because the number of head for this event is 1. Similarly, if you got tail, then it means you got 0 head, right? Then through the random variable x, it will map the outcome tail to 0. But if you define a different random variable, like let's say y as number of tail, then the outcome head, the random variable y will map head to 0, because if you have the outcome head, it means that you have 0 tails, and tail through the random variable y will be mapped to 1. So a random variable is just a mapping from the simple space to some real number. That's it. And you have 2 kind of random variables that you will work with. For this course, I believe we will stop at discrete random variable, but in 256, you will see continuous random variable. So what is the thing that divide the random variable into discrete versus continuous? It depends on the range of the variable. It depends on what values the random variable can output. So for discrete random variable, either the range of the random variable, I call it Rx, is a finite set, or it has to be countably infinite. Finite set is just a set consists of finite number of elements. For example, the set 1, 2, 3. Like it will stop at some point. Countably infinite, we talk about it in the beginning of the course, is some set like natural number, integer, rational number. There are other countably infinite set as well, but in the scope of this course, usually you just see natural number or integer. For continuous random variable, the range of the random variable is uncountable. So it would be some set like the set of all real number, or it can be some interval. Okay, so that's it about the concept of random variable. We have a concept associated with it. The first one is probability mass function. Or normally you will see it being called as PMF. So it assigns what is the probability for each value in the range of the random variable. For example, in the experiment of toss a coin, then you have two outcomes, head or tail. And then the range of the random variable x is just 1 and 0. So x can be 1 or 0. And the probability mass function, you can define it like other function, or you can draw a table like this. That is also fine. We will have to specify what is the probability that a random variable x takes on specific value. The uppercase letter denote a random variable, and the lowercase letter denote a specific value that a random variable can take. For example, here, what do we have to fill in? We have to fill in the probability that a random variable x equal to 0, because we are dealing with a specific value 0. And in here, we will have to fill in probability that a random variable x equal to 1. And let's assume this is a fair coin. Then probability that x equal to 0 means that probability the number of head is 0, which means probability of the tail event, which is just 1/2. Similarly, probability of having one head is also 1/2. You will have to notice that probability mass function, when you add all the probability together, you should get 1. If you don't get 1, that is not a probability mass function. So the important property you need to remember about the PMF is that if you take probability of all possible values of x, it should add up to 1. Here we have 1/2 plus 1/2 is 1. So it's valid. The second concept you need to know is the distribution function. Distribution function will take the domain is all real number. You will have to specify the distribution function for all real number, and it mapped to some number between 0 and 1 because we are dealing with probability. So what does it mean by f of t? It means that the probability a random variable x is less than or equal to the value t. That's all it means. So when you see something like this, it means a probability x equal to t. But when is the uppercase f, it means that less than or equal to. So here, I believe that you can also see this, the lowercase f of t also just mean probability that x equal to t. But when you see uppercase f, it refers to the distribution function, and it refers to less than or equal to sign. Next one is formula for expected value and then variance of a random variable. In order to calculate the expected value of a random variable, you have to go through all the possible value of the random variable, like go through every element in the range of the random variable. And what you do is you take each value and you multiply with the probability that a random variable take on that specific value. For example, here, if I want to calculate the expected value of this random variable x, I have to go through all the value in the range of x. And what I do is I take the value and then I multiply with the probability that x takes on that value. And then I add them together. That is for expected value. And for variance, the most common formula that you use in this course, I believe, is this one. But there is also another formula, which is denoted by this. When mu here is just expected value of x. I feel like this one is more intuitive when it comes to what does variance mean. For expected value, it means average. And for variance, it means how variable or like how spread the values are. So you will take all the values of random variable x and you subtract to the mean, which is like the average, and then you square that difference. And then you calculate expected value of that, which means you want to calculate the average distance between every value to the average. But then normally in this course, I believe this formula is being used more often. I'm not sure if you learned about this, but I will just mention it just in case you see it in the quiz. There's something called linearity of expectation. For example, if you have expected value of ax plus by, it will be a multiplied with expected value of x plus b times expected value of y. And expected value of a constant is equal to the constant. And then variance of ax plus by is a squared times variance of x. Oops, actually not this one. I don't think you learned this yet. So variance of ax will just be a squared multiplied with variance of x. And then variance of ax plus b, where b is some constant, is also a squared times variance of x, because variance of a constant is 0. If you think about it, a constant function means that it only takes on one value. So the value actually does not vary at all. So that's why its variance is 0. Any question about what I just wrote? Let me know if you have any question. If not, then I will let you start working on question 1. Maybe 5 minutes, and then I will take it up. 229. In order to do this question, you might find this formula useful. So this is a summary I made for the winter term, but is the same for this term. These are the 3 formulas from calculus that you should know. First one is finite geometric series. Second one is infinite geometric series. And the third one is just Taylor series expansion of e to the power of x. These are the 3 formulas that you will have to remember because you will use it in the final exam. You can take a screenshot or something.
Is that a 9 to the power of x on the bottom?
Can you repeat what you say?
Is that a 9 to the power of x on the bottom?
Yes, yes. This one 9 to the power of x. Well, the question that they ask you to find a constant c such that something is a probability mass function, I would always suggest you to start with that. The summation for the probability mass function over all value of x has to sum up to 1. So you should use this information and then go from there. So if we use this information here, and you see that the range of x is 1, 2, 3, up to infinity. So we will have to start from x equal to 1 up to infinity. And then the probability mass function at the value x is given by this formula. So I just bring it down. And it has to sum up to 1. C is a constant, so I can pull it out of the summation. If I expand the summation out, you can also pull out 1/9. Yes, we can as well. Let me do that. Let's say I pull out the 1/9, then inside it will just have 9 to the power of x minus 1. And if I try to expand this summation out, so starting at x equal to 1, 8 to the power of 1 minus 1 is 8 to the power of 0 divided by 9 to the power of 0. We have 1. Next one, x equal to 2. I would have 8 to the power of 2 minus 1 over 9 to the power of 9 minus 1. So I have 8/9. And when x equal to 3, I would have 8 squared over 9 squared. And up to x equal infinity. So what we are seeing here is infinite geometric series. And the summation like this would be calculated by taking the first term of the series, here is 1, divided by 1 minus the ratio. The ratio is the ratio between two consecutive terms. So 1 multiplied with 8/9 give me the second term. Second term multiplied with 8/9 give me the third term. Third term multiplied with 8/9 give me the fourth term. So 8/9 is a ratio. So I have 1 minus 8/9 is 1/9. And then 1/1/9 is just 9. And you see that the 2 9 cancel out, and it gives us C equal to 1. So this is our final answer. Any question about this? Even if you didn't pull out the 9 in the denominator, if you just put the 9 still inside, you would still get the same answer. It is just different first term, but the ratio is the same. If there is no question, I will let you work on question 2, probably for 4 minutes. We have a lot to cover today. Okay, so first part, we want to calculate probability that x equal to 2. One common mistake that the student make is they calculate f of 2. They just plug 2 in here and they calculate it. That is incorrect. Why is that? Because f of 2 means probability that x less than or equal to 2. It doesn't mean x equal to 2. Yes, I see the student mentioned here. In order to do part 1, we have probability of x equal to 2 is f2 minus f2 minus. So that is because in order to calculate probability x equal to 2, we want to take the probability that x is less than or equal to 2, subtract probability that x is less than 2. Because when x is less than or equal to 2, it means that x is less than 2 or x is equal to 2. So in order to calculate this quantity, you have to do subtraction. And the first term just corresponds to f of 2 by definition of distribution function. The second quantity corresponds to this. In order to calculate f of 2 is very easy. You just look at the given function and you see, okay, my input is 2. So which situation does it fall in? It fall in the third situation, right? Because here t is at least 2 and less than 3. And your input is exactly 2. So it fall in the second situation, not the second one. The second one does not include 2. The third one is the one that include 2. So you will substitute it into the function given here. Then you would have 2 minus 1 divided by 3. And in order to calculate this quantity, is actually just the limit of the function f as input approaching 2 on the left-hand side. If you see here, this is the input. There are 2 ways you can approach this input. You can approach it from the left-hand side or from the right-hand side. When you have 2 minus like this, it means you're approaching from the left-hand side. If you are approaching from the left-hand side, then what is the output that you are approaching? You're approaching this point, right? And this is calculated by plugging 2 into the second equation. So it is 2 over 6. This one is 2 over 6. So here you have 1 over 3 minus 2 over 6. 2 over 6 is also just 1 over 3. So you have 0. So the probability that a random variable x takes on value 2 is just 0. Normally, that is what happened with continuous random variable. When you see the distribution function is connected like this, then is like the probability of continuous random variable. Probability at one exact value is just 0. For discrete random variable, the probability that x equal to specific value is just the jump of the output at that point. If we just say the limit is okay, do you mean like you just stop at this part and you don't sub in the number? I mean, if we had to evaluate the limit, yes, you have to evaluate the limit. so that you get the final answer for probability of x equal to 2. Okay, let's move on to part B, part 2. We want probability of something given something. So here we are using conditional probability formula. So this is the event A given event B. Then conditional probability formula told us that we would have to take the intersection of them divided by probability of event B. If you think about it, what is the intersection of 1 less than or equal to x less than 4 and x is greater than 2? If we draw out the number line, the first one corresponds to 1 to 4. The second one would include everything greater than 2. So the intersection of the two interval is this part here, right? It will be the part where x is less than, 2 is less than x and x is less than 4. And the denominator, probability of x greater than 2 is equal to 1 minus probability of x less than or equal to 2. Why do I do this? Because we know the function f, the distribution function, which means we know the value of this kind of expression, probability of x less than or equal to something. We know it. That's why we don't want to deal with the greater than. We will want to deal with less than or equal to. I see the student answer mentioned that F4 minus F2. Yeah, that is correct. So what the student did is this probability, he turned it into probability of x less than 4 minus probability of x less than or equal to 2. Because if you think about it, x less than 4 is the whole region here, right? But we only want this region. So what does it mean? We have to take the bigger region, subtract this part. And we also want to subtract 2. We want to subtract probability of x equal to 2 because we don't want to include 2. So that's why we have this. And if we translate it, it is just this expression here. So f of 4 minus is just probability, is f of t, limit of f of t as t approaching 4 from the left-hand side. If we look at this graph, if we're approaching 4 from the left-hand side, it will just give us f of 4, right? So we will have to use this formula because 4 is between 3 and 6. So I will have 4 plus 6 over 12 minus f of 2. F of 2 is here, which is 2 minus 1 over 3. And if you calculate this number, the final answer will be what you want to get. Any question about this? If there is no question, I will let you work on, let me see. So there are 4 questions here. Let's work on question 4. I think it would be closer to your quiz. For a question like this, I recommend you to write out the probability mass function. You can write in the form of normal function, or you can just draw the table like this. So the first row would indicate what is the possible value for x. Here, let's x denote the number of times that the 6 appears. You roll the dice you roll 3 dice. So the minimum number of times that 6 appear is 0, and the maximum number of times that 6 appear is 3. So you should be able to fill in the rest. And then for each of the value, you have to fill in the probability that a random variable is equal to the specific value. And after that, you can find the expected value using this formula. Okay, so we throw three dices, so 6 can appear 0 to 3 times. We want to calculate the probability that 6 appears 0 times. So let these 3 blank denote the result that appear on the 3 dice. And we want the probability that 6 does not appear at all, which means this position has to be something from 1 to 5. 1 to 5 and 1 to 5. So we go like that. What is the probability that this slot takes on some value between 1 and 5? It is 5 over 6, right? Because when you throw a dice, there are 6 possible outcomes, but you are expected something between 1 and 5. So probability that you get anything from 1 to 5 is 5/6. And then the same for the other 2 slots. So it's 5/6 to the power of 3. Next, we want 6 to appear one time. If 6 appear one time, it can appear in the first position, the second position, and the third position. So we have 3 possible positions for 6. And once we figure out the position for 6, we actually want to calculate probability that you get 6 for that position, which is 1/6. And at the same times, you have to get 1 to 5 for other 2 positions. So you have 5/6 to the power of 2. Like this. Next one, 6 appear twice. If 6 appear twice, which means some number from 1 to 5 appear once. So it can appear in the first position, in the second position, or in the third position. So there are 3 possible positions to put some number from 1 to 5 in. And once you fix that position, same thing, you have to find the probability that you can get some number from 1 to 5, which is 5/6. And at the same time, the other 2 position has to be 6. So it is 1/6 squared. For the last one, we want all 3 positions to be 6. Probability of getting 6 for one position is 1/6. And we want that for 3 positions. So it is to the power of 3. Any question about the PMF I just created? Okay, after that, what I recommend student to do is that at the same table, you create another row and you calculate X multiply with the probability correspond to it. So what do you do is at each column, you take the first row, the value of X, multiply with the value of the second row, which is the probability, and then you write that result in the third row. So we have 0 multiplied with anything would be 0. 1 multiplied with anything would be that number. And then I take 2 multiply with this. 6. 3 multiply with this. And then in order to calculate the expected value, you just sum up every values of the last row. So you take 0 plus the second value plus the third value plus the last value. And if you put in the calculator, the final answer will be what we are looking for. Any question about this one? If no, then it's the end of our tutorial. I recommend you to attempt question 3. It's possible kind of questions that you might get on test or exam. So yeah, it will be a good practice for it. Have a good day, everyone, and I will see you on next Monday. Can you post solution to Q3? Yes, I can.